Good afternoon, students. In my last two videos, I have taught you about the chemical reactions, what are the characteristics, and then I came to the chemical equations, formation of chemical equations, then balancing of chemical equations, and I have given you some assignments and some homework to do. Hope you are going on with it. As the school opens, we will submit those homeworks and assignments in your notebook copy. Now today I will be teaching you the different types of chemical reactions. Now under different types of chemical reactions, let me just segregate it. First is combination reaction, then decomposition reaction, next displacement reactions. This displacement reaction is single displacement reaction. Then double displacement reaction, then precipitation reaction, then neutralization reaction, or you can say it as acid-base reaction, and one more is there, that is redox reaction. This is a new thing, redox reaction. Other than this, exothermic reaction, endothermic reaction, combustion reaction, nuclear reaction, certain different types of reactions we'll come across. Now first one for the day is combination reaction. Now combination from the word combination, you can understand it is a combining of either two elements or an element and a compound, or between the two compounds. So combination reaction, we will see it is either, so definition of combination reaction is reaction in which two or more substances. Combination reaction definition is reaction in which two or more substances, that is elements or compounds, combine to form a single substances. With the evolution of heat generally. For example, like 2H2 plus O2 combines to form 2H2O when electricity is passed. We will come into these details afterwards. Now, first combination is between two elements. Combination between two elements. Okay, like if I take iron fillings, when it is heated with sulfur powder, this is also a solid, it will combine. If you heat it, this is the symbol, triangle is the symbol of heat. It will form FeS, iron sulfide. This is also a solid with the heat. This is a combination between iron is an element, sulfur, it will form FeS. One more, magnesium ribbon when burns in air. Magnesium, it's a solid, 2 Mg plus O2 gaseous. When it burns, when magnesium ribbon is burnt in air, it will form magnesium oxide. This is one more compound. Second type of combination, this is A, combination reaction. Next type of combination reaction is between an element and a compound. Like sulfur dioxide, this is B. Sulfur dioxide reacting with oxygen to form sulfur trioxide. 2SO2 plus O2 gives 2SO3. sulfur dioxide is a compound reacting with oxygen molecule to form sulfur trioxide. Another one is 2NO plus O2 gives 2NO2. Nitrogen oxide reacts, burns in oxygen to give nitrogen dioxide. This is nitrogen dioxide. Everything I have given in my notes, nitrogen dioxide. This is sulfur trioxide. Here, in this heat is liberated, in this heat is absorbed. 2NO plus O2, 2NO. And third type of combination reaction is between two compounds. Between two compounds. Between two compounds. Like ammonia gas. It's a gas. When HCl gas is passed, it forms ammonium chloride, NH4Cl. It forms NH4Cl. You will see white fumes. If you bring, or if you can take aqueous also in this, aqueous also you can take. Ammonia gas, when you part HCl, when you take a test tube, in HCl, when you pass ammonia gas, you will see white fumes of ammonium chloride coming out. Another one example is calcium oxide, quicklime. This is called quicklime. Quicklime, when added to water, चूना, जिसको हम लोग हिंदी में you say चूना, added to water, it forms calcium hydroxide. It is called slaked lime. Slaked lime. With the evolution of heat. So this is also, you can say this is a combination reaction, but at the same time you can say it is a exothermic reaction because heat is liberated out. Here endothermic, here exothermic. So I told you, you can say exothermic or endothermic reaction. Now, so this slaked lime. Now you have seen we are whitewashing the walls. All you have here that we are taking quicklime, adding to water, and then we are whitewashing the walls. You know, this whitewashing, when you do that today, if you do whitewashing, immediately in the evening or next day you will not see the glaze on the walls. Why? You know, what is the reason behind it? Actually, this calcium hydroxide, when this calcium hydroxide combines with the carbon dioxide present in the atmosphere, it forms calcium carbonate and water. This calcium carbonate gives a shiny appearance on the wall. This gives a shiny appearance on the wall. Remember, you may be asked in the exam, why don't you see the shiny appearance on the walls immediately after whitewashing? Because unless and until it absorbs carbon dioxide from the atmosphere, it will not form calcium carbonate. Because of the formation of calcium carbonate after 1 or 2 days on reaction with carbon dioxide, it will give a shiny appearance on the walls. So this is the different types of combination reaction. I hope this much is clear to you. Now next topic which I am going to discuss is decomposition reaction. So combination reaction is reaction between two elements, iron and sulfur, between an element and a compound, sulfur dioxide, oxygen, and between two elements. Ammonia plus, this is ammonia, this is called ammonia, and this is ammonium chloride. This you called it as ammonium chloride. Quicklime reacting what is slaked lime. Okay, let us come into the decomposition reaction. Now coming to the decomposition reaction. First of all, what is decomposition reaction? Decomposition reactions are those reactions in which a compound, like AB, suppose a compound A, suppose A is a compound which breaks to B and C. That means suppose reaction in which a compound breaks down into two or more simpler compounds by the in the presence of heat, light, electricity or catalyst. They are called as decomposition reaction. So decomposition reactions are those reactions which takes place in which a substance, a complex or compound, breaks into two or more simpler substances in the presence of heat, light, electricity or catalyst. That means decomposition reactions can take place in the presence of heat. Number one, A. This heat you called it as thermal decomposition reaction. Thermal decomposition reaction. Second one, by electricity, or you call it as electrolysis. You can see the electrolysis. And one more, that is by sunlight. This type of reaction you call it as photochemical reaction. Photochemical decomposition reaction. So first, decomposition reactions are there in the presence of heat, electricity and sunlight. And one more thing, one more very important thing, decomposition reaction is just the opposite of combination reaction. What happens in combination? A plus B combines to form C. And here in displacement decomposition reaction, A breaks to form B and C. So combination reaction and decomposition reaction are just the reverse or the opposite. Now let us take decomposition reaction, that is by the process of heat. For example, if you take heating of lead nitrate, heating of lead nitrate, heating of lead nitrate. Now, when you heat lead nitrate, 2PbNO3, lead nitrate formula is 2PbNO3. When you heat it, it will form 2PbO, lead oxide, with the formation of NO2, nitrogen dioxide, and also oxygen gas. So when you take this lead nitrate in a test tube, okay, it will form lead oxide, nitrogen dioxide, and also oxygen gas. Okay, so it will make, when you take this material in the test tube, it will give a cracking sound. That means it is breaking up, the bond is breaking up to form lead oxide, nitrogen dioxide and oxygen gas. This, how will you know that nitrogen dioxide? You will get brown fumes. You will get brown fumes. And if you bring a mastic, glowing mastic, you will see the flame is more brighter, which will show that oxygen gas is released. Okay, and you can see in the book also the diagram is given. Okay, one more type is decomposition is heating of ferrous sulfate, FeSO4, 0.7H2O. This you call it as green vitriol also. This you call it as green vitriol also. Green vitriol. Okay, like copper sulfate, you say it as blue vitriol. Here you say it as green vitriol. So when you heat first FeSO4 0.7H2O, when you heat it, you will get FeSO4 plus 7H2O. Ferrous sulfate. This you get it as ferrous sulfate. Now this ferrous sulfate, when you heat further, you can see when you take it in a test tube, you will see water droplets on the outer side of the test tube. Now when you heat this ferrous sulfate strongly, you will get Fe2. This is white in color. This is white in color. Fe2O3, ferric oxide plus sulfur dioxide plus sulfur trioxide. This you get sulfur dioxide and sulfur trioxide. This ferric oxide is brown in color. And how will you know sulfur dioxide and trioxide is coming? You will get the smell of sulfur. So this is thermal decomposition reaction. This is thermal the decomposition reaction. Next is by electricity. By electricity. Hope this is clear to you. Thermal decomposition. Heating lead nitrate, you get lead oxide, nitrogen dioxide and oxygen. Heating ferrous sulfate, first you heat, they remove the water molecules, FeSO 4.7H2. Further when you heat it, you get ferric oxide, brown, and sulfur dioxide and sulfur. Smell of sulfur. Now by electricity. This is when you decomposition of water. Decomposition of water. You take water, H2O liquid, when you pass electricity. When you pass electricity, you will get 2H2 gas plus O2. Now, how will you know that it is a decomposition reaction? For this, you can see in the book also, this year, it came in the board exam also. You take a beaker, make 2 holes at the bottom here, and connect, join 2 electrodes, carbon electrode, graphite electrodes, okay? Graphite electrodes. Now this you connect it to the battery. Fine. Now, this is, you take it as anode, the positive electrode, and this you take it as cathode, as the negative electrode. Fine. Now, you invert 2 test tubes like this. You invert 2 test tubes. Okay, you invert 2 test tubes. Now, in these test tubes, now you take acidified water. Whatever you are taking, you take water. That water should be acidified. Acidified water you take. Acidified H2O. You add small amount of dilute H2O so that the electrolysis goes on faster and the breaking of the ions takes place very smoothly. Now, you will see the gases are collected in this 2 test tube. At anode, you will be seeing oxygen gas here. In anode, oxygen gas is collected, oxygen, and at cathode, you will have hydrogen gas. Hydrogen gas will be collected. At anode, oxygen gas, and at cathode, hydrogen gas. And the ratio of the gases will be, that is the hydrogen to oxygen. This to oxygen will be 2:1. If it is this much, oxygen is this much, hydrogen will be up to this much. So the ratio of hydrogen to oxygen will be 2:1. Next thing, how will you identify which is hydrogen, which is oxygen? Now, if you turn this test tube and bring a matchstick near both the test tube in hydrogen, it will the flame will put off with a pop sound, and here the oxygen, it will burn with the glowing flame. So this is the decomposition by electricity. So when you pass electricity, it breaks up into hydrogen and oxygen, and the reaction is shown. It's there in the book. It's very, very important. This time in the board exam, this question was there. Which gas will be collected at cathode? Which gas will be collected at anode? Why is the ratio 2:1? And why do you add dilute H2SO4 to that? Okay. Now the third one, by sunlight. By sunlight. This you call it as, already I have written, photochemical reaction. This you call it as photochemical reaction. Like in the older days, now like 10 years back, you were using these negatives to take the photographs, and we were telling don't take these negatives to the that reel, camera reel, to the sunlight. It will get damaged. So what happens? These camera reels and all they were having, that reels were made up of silver chloride, AgCl or AgBr, silver chloride or silver bromide. So when you took AgCl, you put it in sunlight, it will form 2Ag plus Cl2. So this is photochemical reaction. This will give a gray color. This will give a gray color. This silver chloride is white. When you get it into the sunlight, it will change into gray color. Okay, same way you can do it. Now, this decomposition reaction what are the uses of decomposition reaction? First of all, they are used in metallurgy, and secondly, for electrolysis, and digestion of food in our body is also a type of decomposition reaction. Hope you have understood. Decomposition reactions are of three types: by heat, thermal decomposition; by electricity, electrolysis; and by sunlight. So I have given you. Maybe if you have anything to ask, you can put questions to me. Already I have mailed the notes. If you have doubts, you can ask me. Now next is displacement reaction. Displacement reactions are of two types. One single displacement reaction, another one is the double displacement reaction. Now displacement reactions are, what do you mean by displacement reaction? In these reactions, a more reactive metal displaces a less reactive metal from its salt solution. Okay, a more reactive metal displaces a less reactive metal from its salt solution. For example, you have done this when you take iron nails. This is solid. When you add to copper sulfate solution, this is blue in color. After few minutes or 10 minutes, if you see, you will see the color of the blue copper sulfate solution will change to green, light green, and you will see a copper deposit over the brown copper deposit over the iron nails. That means a more reactive, that is, this iron is more reactive than copper. It will displace copper from its copper sulfate solution to form FeSO4, giving green color with a deposition of copper on the iron nails. Now, one more reaction is, if you take copper adding to silver nitrate solution. Copper, when it is made to react with silver nitrate solution. Okay, this is silver nitrate solution is it is colorless. It is a colorless solution, silver nitrate. When you put it into it, you will see it forms copper nitrate. The solution, color of the solution will change to blue, and you will see a silver deposit over the copper metal. Okay. Now, how this reaction? Here also same thing. Copper is displacing silver from silver nitrate solution. That means a more reactive metal is displacing a less reactive metal from its salt solution. Now, this is taking place by the help of the reactivity series. Reactivity series, I think everybody has studied in class 8, reactivity series or activity series. Now, what is reactivity series? Arrangement of elements or metals in the decreasing order of their reactivity. Arrangements of elements or metals in the order of their decreasing reactivity is called reactivity series or activity series. Now, to remember how to, first is potassium, P, then sodium, S, sometimes it is P, then barium, B, then calcium, PS, BC, mesentery, M, magnesium, A, aluminium, Z, zinc, I, iron, N, nickel, T, tin, L, lead. PS, BC, mesentery. This is the order. P for potassium, S for sodium, B for barium, C for calcium, M for magnesium, A for aluminium, Z for zinc, I for iron, then one cobalt is also there, cobalt, then nickel, then tin, and then lead. And after that comes hydrogen. After this comes hydrogen, and then comes copper, mercury, then silver, then gold, and then platinum. This is the reactivity series. In this way the series goes. So you see here, if you see here, iron is here, it is more reactive than copper. So it can displace copper from copper sulfate solution. Here you see copper is more reactive than silver. So it can displace silver from silver nitrate solution. But if you take the reverse reaction like Cu plus FeSO4, there will be no reaction. No reaction. If you take silver plus copper nitrate solution, there will also be no reaction. So this is this is called single displacement reaction. You term it as the single displacement reaction. So till now I have taught you about combination reaction, decomposition reaction, displacement reaction, that is single displacement, and then about the reactivity series. Now coming to the double displacement reaction. In this double displacement reaction, what happens is the reaction in which two compounds mutually exchange or react. Two compounds react to form two different compounds by mutual exchange of their atoms. So double displacement reaction is those type of reaction in which two compounds reacts to form two other compounds by the mutual exchange of atoms or groups. Like if I take a simple AB, here A plus B minus reacting with C plus D minus. It will now A will go with C, A will go with D, and C will go with B. That means it will form A plus D minus plus C plus B minus. So this is called as double displacement, mutual exchange of partner. Now in this, suppose if I take the simplest type, and double displacement reaction can also be, you can name it as precipitation reaction, reactions. Like if I take barium chloride solution, barium chloride, it is aqueous. When I add sodium sulfate to it, Na2SO4, it will form barium sulfate, BaSO4. You will get a white PPT, aqueous. It will get white precipitate, white PPT of barium sulfate, white PPT of barium sulfate with NaCl. This is the barium chloride and sodium sulfate. This is barium chloride and sodium sulfate. So you can, the double displacement reaction, you can say it as precipitation reaction. This is a type of precipitation reaction. One more example is lead nitrate, PbNO3, lead nitrate reacting with potassium iodide solution. You get, already I have taught you before, lead iodide plus potassium nitrate. You will get yellow PPT of, yellow precipitate of lead iodide. So this is also a precipitation reaction. This is also a precipitation reaction. It is also may be termed as neutralization reaction, that means acid-base reaction. The simplest, what is a neutralization reaction? A neutralization reaction is one in which an acid or a base reacts to form salt and water, like HCl plus NaOH. This is hydrochloric acid reacting with sodium hydroxide, a base. This is a base to form NaCl plus water. It is called sodium chloride. It forms sodium chloride salt plus water. This you also call it as neutralization reaction. This you also call it as neutralization reaction or acid-base reaction. One more reaction, if you take H2SO4 plus NaOH, it will form Na2SO4 plus 2H2O. Same way it is a neutralization reaction. Okay, so this you term it as the double displacement. So in under double displacement reaction, this precipitation as well as neutralization reaction comes. And here it is redox. Now, all this combination, decomposition, displacement, double displacement, hope you have understood properly. Now, I will be giving you some questions regarding this. So, please you try to write those questions in your notebook and follow it. The questions are like, why is double, like my questions can be, why is the double of amount gas collected in one of the test tube in the electrolysis of water than the amount that collected in the other test tube? Means why is that double? I have already told that hydrogen and oxygen is collected in the ratio of 2:1. Why? In that only name the gas collected at anode as well as cathode, and why H2SO4 is added to it. Second question, why are decomposition reactions called opposite of combination reaction? Explain with chemical equation. My second assignment question. Third question, which is very very important, write one equation each for decomposition reaction where energy is supplied in the form of heat, light and electricity. That means heat means thermal decomposition, light means photochemical decomposition and electricity. Fourth question is explain with precipitation reaction and neutralization reaction. And one more, differentiate between displacement and double displacement reaction. Difference between displacement and double displacement reaction with equations. Everywhere you have to follow the equation. I can see each and every equation I have given you, this reaction I have given you equations. So equations are very 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 important. Okay, and what do you understand by reactivity series of metals? And arrange, suppose elements may be given, to arrange them in their order. Now next important topic which I will discuss is redox reaction or oxidation reduction reaction. So we have seen till now combination reaction, decomposition reaction. Combination reaction of three types, then decomposition reaction by heat, light, electricity, then single displacement reaction, and then double displacement reaction. In that we learnt about precipitation reaction as well as neutralization reaction. And also we learnt about the reactivity series, that means in which metals are arranged in the order of their decreasing reactivity. Okay. Now the last one which you are going type of reaction which you have learned, you are going to learn it for the first time, that is redox reaction. You called it as, redox means simultaneous oxidation and reduction reaction. Simultaneous oxidation and reduction reaction, you called it as the redox reaction. Now what do you mean by this? For this let us take an example. Suppose if you take copper. Copper is a brown metal. You take it in a bowl and then you heat it. When you heat this copper, you will get a blackish mass of copper oxide. You will get blackish mass, black mass of copper oxide. Okay. Now this black mass of copper oxide, through which if you pass hydrogen gas, you will see you again get back the brown copper metal. Now why this happens? Okay, why this reactions happens and how it happens? So here in this reaction you can see copper oxide on heating with hydrogen gas, you are getting copper and water. So what is happening? Copper oxide is forming Cu. Okay, copper oxide is forming Cu when you are heating it with hydrogen gas, whereas hydrogen is forming H2O. So here copper oxide is losing oxygen to form copper, whereas hydrogen is gaining oxygen to form H2O. So the gain of oxygen or loss of hydrogen is called oxidation. Loss of oxygen or gain of hydrogen is called reduction. So here reduction is taking place, reduction, and here oxidation is taking place. So what is oxidation reaction? Oxidation reaction is gain of oxygen or loss of hydrogen is called oxidation. Loss of oxygen or gain of hydrogen, you called it as reduction. You called it as reduction. Now here copper oxide is undergoing reduction to form copper. That means copper oxide is getting reduced. So copper oxide is reduced to copper, and H2 is oxidized to form H2. So here reduction is taking place, here oxidation is taking place. Now in the same reaction, who is helping H2 to form H2? Who is helping H2 to form H2? That means copper oxide. Copper oxide is losing electron, losing oxygen to form copper. That means copper oxide is helping H2 to form H2O. So this CuO is oxidizing agent. Oxidizing agent. And who is helping or making CuO to lose oxygen and form copper? That is hydrogen. It is a reducing agent. This is reducing agent. So what is oxidizing agent and reducing agent? The substances or agents which helps in oxidation, they are known as oxidizing agent. The substances or agents which helps in reduction, they are known as reducing agent. So this is very, very, very important. In the exam you may get a 2 marks question. Name the substance: oxidized, reduced, oxidizing agent and reducing agent. So you have to show which is getting oxidized, which is getting reduced, which is the oxidizing agent and which is the reducing agent according to that. Now one more example let us take. Fe2O3 plus 3CO. It forms 2Fe plus 3CO. Here you see ferric oxide, iron 2,3 oxide reacting with carbon monoxide to form iron and carbon dioxide. That means CO is getting oxidized. CO is getting oxidized to CO2. Here it is oxidized. CO is getting oxidized to form CO2. That means here oxidation is taking place. Here oxidation is taking place. And Fe2O3 is losing oxygen to form Fe. Here reduction is taking place. Here reduction is taking place. That means Fe2O3 is reduced to form Fe. Here reduced. Fe2 is getting to reduce. So which is the oxidizing agent here? Fe2O3 is helping CO to form CO2. So this is oxidizing agent, and CO is making Fe2O3 to lose oxygen and form Fe. So it is reducing agent. This is reducing agent. Now I am giving you one more example. You try to do it of your own. MnO2 plus 4HCl forms MnCl2 plus 2H2O plus Cl2. You have to identify which substance is getting oxidized, which substance is getting reduced, which is the oxidizing agent and which is the reducing agent. Just for hint I am giving, MnO2 is losing oxygen forming MnCl2. That means MnO2 is reduced. HCl is gaining oxygen to form H2O. That means HCl is forming H2O. That means oxidation. And then you have to write which is the substance oxidized, which is the substance reduced, and which is oxidizing agent and which is the reducing agent. So this is a very important thing which will help you in future also, redox reaction. That means since in the same reaction simultaneously the oxidation and reduction is taking place, so this is a redox reaction. Simultaneous oxidation and reduction is called redox reaction. The substance which getting oxidized, that means gaining of oxygen or loss of hydrogen, is called oxidation, or loss of oxygen or gain of hydrogen is called reduction. Okay, and the substance which helps in oxidation, they are known as oxidizing agents. The substance which helps in reduction, that is known as reducing agents. So I have explained it with two examples. I will be giving you some more questions for assignments. Please try to do and bring me. Now the last part which I will come, what are the applications of redox reaction in our daily life. Now we have just now learnt about redox reaction. Now we will go through the applications of redox reaction. Now in these applications, two main applications of redox reactions are, first one is corrosion of metal. Corrosion of metals. And second one, rancidity. This is a new term which you will be learning, rancidity. Okay. Now what is corrosion? Corrosion, it is the process of deterioration. That means the quality of the metal decreases. The deterioration is the process of deterioration of metal as a result of its reaction with air and water. That means to have corrosion to take place, we need air or oxygen, and second you need is water or moisture. Okay, air corrosion, that means that it is the process of deterioration of metal as a result of its reaction with air and water. Now, corrosion of metals is a normal term. If you take corrosion of iron, if it is corrosion of iron, then you term it as rusting. Corrosion of iron, you term it as rusting. Rusting. Okay, you term it as rusting. Okay, now what is rust? Rust is hydrated iron oxide. Rust is hydrated iron 3 oxide. Hydrated iron 3 oxide, that is Fe2O3.XH2O. Okay, so for corrosion or rusting to take place, two things are needed. That means either air or oxygen or water and moisture. If one of them is absent, corrosion of metals will not take place. Okay, like silver metal tarnishes leaving a black coating. Okay, surface of copper acquires a green coating because of the formation of basic copper carbonate. These are all related to corrosion. Next is rancidity. Now what is rancidity? Now the definition is the change in odor or flavor. The change in odor, let me smell, odor and flavor of oily and fatty food materials by oxidation. By oxidation is called rancidity. That is change in odor and flavor of oily and fatty food materials by oxidation. Now in this, the smell or the flavor of the food gets spoiled and it gives a foul smell. Mainly it is for oily food. So This is because this fat and oily foods get oxidized. They get oxidized, forming a different compounds, and the food gets spoiled. Now, what are the methods you will apply to prevent rancidity? Methods to prevent rancidity. First of all, first method is by adding antioxidant. By adding antioxidants like BHA. What is the full form of BHA? That is butylated hydroxyanisole. The formula is butylated hydroxyanisole. And another one is BHT, butylated hydroxytoluene. This will BHT, no? BHT. It is butylated hydroxytoluene. Means it's just a cut of the oxidation. It will help in prevent in oxidation, antioxidant. Second one, by keeping them in airtight container. By keeping in airtight container. By keeping them in airtight container. Third one, by refrigerating. And fourth one is by vacuum packing. That is, they are being flushed with inert gases. Flushed with inert gases like argon, nitrogen gas, etc. So what are the methods? What is rancidity? Changing odor and flavor of oily and fatty food materials. Methods to prevent: by adding antioxidants like BHA, butylated hydroxytoluene, BHT, butylated anisole and butylated hydroxytoluene, by keeping in airtight container, by refrigerating, by vacuum packing, like using in inert gases. So like chips and chips packets, they are being flushed with inert gases so that the foul smell of the food items doesn't come out. So these are the certain. By this I end up the chapter, and if you have, I think I have explained you whatever is there in the book. You should go through the notes what I have provided in the in my email. My notes already have uploaded it. So whatever, if you have doubts, you can ask me, and have given you some more questions you should do. Like the question is, why oil and fat containing food items are flushed with nitrogen? This is one question. Why do you paint aromaticals? Then a shiny brown element X, on heating in air it forms black. Okay, so name the element X and show the reaction. And I have given you rancidity. What is rancidity? How can you prevent rancidity? What are the methods to prevent rancidity? Then define rancidity and write some methods to prevent rancidity. Next question you can take, I already given, but then again also explain corrosion. Okay, and I have given you some question based on oxidation and reduction. You have to write name which is the substance oxidized, which is the substance reduced, oxidizing agent, and these all assignments you will do it in your copy, classwork copy. not copy, and after the school reopens, after the lockdown, you please submit it as early as possible, so that it will make me come to know that whether you have understood the chapter, and after the reopening, if you have any doubts in any part of the topic, I will make it clear. With this, I end up the lecture. Thank you. Have a good day.